So today, as we take a look at the properties of logarithms, this very first statement on the top can kind of wrap most of this up. Logarithms have properties that are similar to those of exponents. The exponent rules that we talked about before, which is when we're multiplying with exponents, we add. When we're dividing with exponents, we subtract. And the one that's going to be different is the power to power, because we're not going to be doing, power to power, we multiply the exponents. That's going to be a little different. But let's take a look at this. Product property. Again, product is when we multiply. Thank you. Multiplication becomes addition, just like it does with exponents. Okay, the quotient property, when we divide, division becomes subtraction, just like exponents. Now, this is the one that's a little different. The power property. If you have an exponent on one of your terms, that is going to swing around to the front and become a coefficient. And when we get to the other part of this, called condensing, it's going to do just the opposite. It can go from the front back up into an exponent. So these are kind of your tools in the toolbox, especially when we get to the solving part, that you're going to need to be able to find some success. So as we get into part one here, using the properties of logarithms to evaluate the expression, I have come to a realization. And the realization is this. Now that I showed you ahead of time how change of base works, I'm assuming most of you are going to do that on this. Now, maybe not. So I am going to take the time here on number 5, sort of like what we did last week, to show you how it works if you decide not to use change of base. So, we'll pull the calculator up here. We'll need it in a minute. So log base 2, 4 to the 5th. Okay, first thing, let's see what 4 to the 5th is. Okay, 1,024. Now, it used to be, back in the day, that if we wanted to start figuring this out, what we were trying to consider or think of was my base 2 to what power equals 1,024. I mean, and that could take a while. I mean, you sit there and you're like, well, that's not even close. Okay, I'm getting a little closer. And you would kind of just mess with this stuff until you finally found it. Okay, because we were like 2 to what power equals 1024. But we have found over time that there's a way that goes faster. I can take this same piece and use change of base, which we've discussed before is log of big, the physically larger number to the right, divided by log little, or in mathematical terms, log of our of over log of our base. And the only thing really I got to remember with these, to make sure I don't mess this up, is to close my parentheses as I go. And that each of them are actually logs. And I get the same answer. So I really am going to assume that about 98.75% of you are going to decide to go this route instead of trying to think about it. Okay? So log big, physically big number, divided by log little. Now, what happens, though, if I get into a problem like number 7? Do I have to do them separately? What do I do? No. 3 times 9, I can go ahead and do that. There's not a problem with doing that at all. And so I would just do my change of base and get my solution. So whenever we see these, like I said, I'm going to assume that you're not going to think 3 to what power is 27 and get 3, which it is, it's true, that you're probably going to use the change of base instead. But when we get to part 2 into part 3, now things are going to change up a little bit. we're going to do these two things called expanding and condensing. Now, if you think about those words, and you've had any experience with them, expand means something gets bigger. It stretches out. It gets wider. Condense means something gets kind of packed in a little bit. Okay? So, expand means we're going to take this one single log and we're going to stretch it out. So here's how we're going to do this. We're going to kind of be methodical and do it in a certain order. So we're always going to look, when possible, we're going to do our quotient property first. Our product property second. And our power property third. And I've got my reasons for doing them in this order. It keeps us from running into confusion on what I can do and what I can't. Is it possible to do it some other ways? Yes, but it's definitely not as easy. So here's how this is going to work. Now, quotient. So I start thinking about that. I'm like, okay, that's divide. But here's what I'm looking for when I'm expanding, okay? Quotient means divide. Whoops, got to bring it down here. Divide becomes subtract. So, do I see any dividing? Do I see any fractions? I do. So my first step is going to be to take that division part. So log 2, 7x to the third. When the division sign comes, I replace it with a minus. And then I rewrite my log in the denominator. So the only thing I did this entire time was turn divide into subtract. Okay, everything else stayed the same. So once I take care of any dividing, then I move to product. Okay, product. If I look up above, it means multiply becomes add. You're like, well, I don't know if I see any multiply. Remember, if there's a place in anything where a little multiplication dot would fit, 7 times x to the third. Okay? That's going to be where our focus is. So how's this work? Well, I'm going to do log base 2 of 7. As soon as the place where the multiplication dot would be shows up, I put a plus in there. And then I rewrite my log with the second piece. So 7 times x to the third becomes log base 2 of 7 plus log base 2 of 3. Last part stays the same. There was no multiplying there. It's just y. And then we get to our last one, power. Now a power means, is there an exponent? Do I see any exponents? I do. So now what? How does that change things? That exponent is going back to the front of that particular term. So the log base 2 of 7 didn't change. But here, that exponent moved to the front. So it's not an exponent anymore. It literally moved. So once I get to a point with these that I see no more multiplication on this side, I know that'd be 3 times log, but that's a coefficient now. I don't see any more division. I don't see any more fractions. I don't see any more exponents. I'm done. But that's why we like to do them in order. Because this way, once you do the power at the end, once you do any of those, you know you're done. You're not sitting there going, am I done? I'm not sure if I'm done. Am I really? You're going to be sure. Because you've done the things in order. And the only time that we even slightly take this out of that range is going to be in a situation like this, where I've got an exponent and there's multiple things going on inside. If that happens, I do need to go ahead and get that distributed out right away. Okay, so this original problem looks like this. Once I get there, I start running my steps. I go, okay, quotient, do I see any divide? I do. So I take my log. When I get to the divide, I put a minus. And then again, I've got to write the log again. I can't just write 7 squared minus 9 squared. That actually changes the answer. So I get that in there. Do I have any products? I do not. I don't have like log 7x or 9x or something like I did back here in the first one. So we don't have a step 2. So I'm going straight to step 3 because I see I have exponents on both terms that got to come back to the front and become coefficients. As long as I've done them in order, I should see no more fractions, I should see no more multiplying of log terms, and I should see no more exponents. And we're set with that. So it shouldn't be too bad. Thank you. All right. So then 11, my last one, this is kind of the big one that we get lots of things going on. So I look at number 11. Do I see any fractions? No. Do I see products? Oh, do I see products? Because again, remember, if I can put a multiplication dot in there, 2 times x squared times y, each place I see that multiplication dot, I'm going to be putting a plus in there. So we didn't have a step 1 part, but we do have a step 2. So log base 3 of 2, wherever the multiplication dot would be, we put a plus. Start again with my log, x squared, see a multiplication dot, start my plus. So multiplication dots replaced by pluses. And so once I get there, now I'm to my last step. I'm to my power step. Do I see any exponents? Only one. So my last step, and that's the thing that people gripe to me about. They're like, gotta rewrite this all again. What the heck? And I'm like, you know, it could be worse. It really could. But I made it. So that's expanding. Quotient, products, power. QPP. Just got to keep my P's straight. So you're like, oh my gosh, we still got this condense thing. Okay, condense, you'll never guess. We're doing just the opposite. We're going to take these longer ones, like we see in our answers here, and we're going to smash them all the way down to a single logarithm, like 9, 10, and 11 are at the start. Here's the only catch. I guess we could call it a catch. My order up here, if I'm undoing it, well, how should I do it? The opposite way. So with these, we do power first. So the exponents are going to go back to, the coefficients are going to go back to being exponents. Then we do the product. So our pluses are going to turn back into multiply. And then we do our quotient. Our minuses turn back into division. Okay? But it's just doing them all backwards. We're undoing them. So, when we start to look at those, again, we want to keep that same order. So, power. Now again, I'm not looking for exponents here. I'm looking for coefficients that are in front of my log. Those are going to turn back into exponents. So here, log 6 plus log 2 squared, there's my 2 back as an exponent, minus log 3. And I would suggest doing them one at a time and not trying to do multiple steps at once, because that can really get messy. Okay, product. I don't have any. Yes, I do. What am I talking about? Product. Remember, Harty, you're going backwards. We're not looking for times. We're looking for pluses to turn back into times. So right there. Okay, so we're going to deal with this next. So log, now remember, we're trying to get it down to 1. 6, the plus will now become times 2 squared. See, I even have to think about it a little bit. Coefficient to exponent. Add goes back to being multiply. And now quotient, again, I'm not looking for division. I'm looking for subtraction. I see it. So now what's this going to look like? Let's see. It's going to be one big old log. 6 times 2 squared. The minus, there's my division, there's my fraction bar. 3. We're back to 1 log. We've condensed. And I'll usually have some people say, well, do I multiply this all out? Do I make it 6 times 4 over 3 and actually reduce it all the way down? You can, but this shows me you know what you're doing. Okay, so you don't have to do extra work with that. Sometimes I'll show my answers like this. Sometimes I'll also show them completely simplified. But again, it's just going to take some practice. So I go to 13. I go, okay. Do I see, any coefficients? People will normally look at this 5 and say, yes, that's a coefficient. It's not. Why not? Coefficients are going to be in front of my log. That 5 is not in front of my log. Okay, that's part of my of value. So no, I do not have any power. So I do not have any power. Well, I have some. Okay, product. I do see a plus though. So log base 8, 5x squared times 3. So plus became times. I don't see any minus. So I don't have any quotient. So one step had me good that time. And again, I could multiply that together and call it 15x squared. You can. It's not wrong if you do. Not wrong if you don't. So we get 7 on that one. So as you can see, we may not have all 3 on these. We may only have 1. We may only have 2. It depends. So I get to 14. Okay. Power. Remember, power is coefficients in front that go back to being exponents. Base 4x to the third. Now notice, I'm not taking -2. This isn't becoming y to the -2nd. Leave the symbols alone. Just take the number. Okay, so coefficients back to exponents. I do not see any plus, so we will not have a product this time. But my quotient, because I do see minus, x to the third divided by, my minus becomes divide, y squared. Single logarithm. It's not, you'll notice, log 4 x3 over log 4 y2. That's a different answer. One log. One log, one log, one log. That's why we call it a single logarithm. That again, between today and tomorrow and the quiz preview, we're going to see it several times, but you've got to do your due diligence and practice. Yes, sure. And then finally, down here at the bottom is something we've seen a couple of times already now. Okay, change of base. When we're evaluating, okay, we're rounding to the nearest thousandth, which is 3 decimal places. Log big divided by log little. And you can get answers that are not pretty with these. Okay, let me move this back up for a second. Log, remember, is down here next to the 7. Convenient that we need the 7. Now that wouldn't have been very helpful. I'd have hit enter and I'd have been like, yeah, that's it. No, I didn't put a divide symbol in there. That's kind of important. So again, 3 decimal places. If that 2 would have been 5 or above, I'd have gone to 0.772. And the reason I say that is when we get to 16, this is going to be a little more interesting with our rounding. So log big divided by log little. when I get to this one, and I hit enter, my initial may be to put 7.199. But can I in this case? No. The 6 rounds the 199 up to 200. Now, I am not going to get into an argument here over significant digits. If you want to do that, you need to go argue upstairs in the science department. Sorry, science teachers. If you put 7.2 here, I would take it. Because rounding-wise, that's an equivalent value to me. Okay? But the big critical thing here is going to be practice. All right, thank you. So, especially with 20 minutes of work time, asking you to do a monstrous 2, 4, 6, 8, 9 problems is really not a terrible thing by any means. We will have a worksheet tomorrow to double up on this. We'll have a preview to triple up on this. And then we'll be quizzing. So use your time well. Key is up in the front. If you've tried it and it still ain't clicking, come see me. Don't wait. Alrighty. The lineup is begun.
Would this answer right here be different if that was not log 4?
You will not run into that situation here, but yes, it would, because I wouldn't be able to condense unless the bases are the same.
Okay.
Would I be able to come during advisor?
Sure.
I have two.
You got to get some stuff made up. That is a good plan. I'm going to forget to do attendance if I don't get this up. It's going to be bad. Bad. Alrighty.
Sorry, can I come in and take that quiz?
Alrighty. Alright, so here, I went ahead and I distributed that through first. So here, I'm going to leave it with the exponents. So once I get here, now I've got a couple of things going on. I've got a quotient, which is going to become minus. So normally, I would squeeze in one thing before where we got you to there. And then my coefficients are swinging back down and becoming 2 log 7 minus 2 log 9. Alrighty.